Okay, so let's begin. So this is EEEE. I would like to call it Module 1 Revision, and today's date is 2nd September 23. Okay, so I think we'll start with theorems. So we have four theorems. Thevenin's theorem. We'll start with Thevenin's theorem. So what this thing says is, what this theorem says is that if we have any complex circuit, okay, any complex circuit consisting of R, then voltage source, then current source, looking in a very complex manner, and we take out the terminals at the output A and B. All right, and this circuit can be replaced according to the Thevenin's theorem by this complex circuit can be replaced by a single voltage source in series with a resistance. Now this resistance is called as RTH, and this voltage source is called as VTH. All right, so this A and B, this entire circuit over here has converted into a single voltage source VTH in series with a single resistance RTH. Did you get it? So this is my complex circuit, and this is the Thevenin's equivalent. All right, and between A and B we can connect a load resistor RL. Here also RL. Is this thing clear now? Here VTH is called as Thevenin's voltage, and RTH is called as Thevenin's resistance. Alright, so again I repeat, any complex circuit consisting of resistor, voltage source, current source, and you take the points at the output A and B. Alright, RL is the load resistor. Now this complex circuit gets converted into a single voltage source in series with a single resistance, that is RTH, VTH and RTH. VTH is called as Thevenin's voltage, RTH is called as Thevenin's resistance. You're able to hear and it's clear? Yeah?
Yes, sir.
Alright. So next we will find out that how to find the value of VTH and RTH. Alright. So please write it down. VTH, how to calculate VTH. So our aim is to calculate VTH and RTH. That's it. Alright. And then the Thevenin's theorem will take over, and then we'll draw the circuit, and yeah. So let's write it down how to calculate VTH. In order to calculate VTH, you need to remove RL, remove load RL. Okay, RL is connected between A and B terminals. All right, and then next step may calculate. I can write it in terms of 1 and 2. So this is first step. Second step is to calculate voltage across A and B terminals. And this voltage across A and B terminals is called as VAB, or we can call it VTH, or it is also called as open circuit voltage. This is open circuit voltage. Have some patience. We will get to know all these things when we'll actually solve a numerical. So this is the way we calculate VTH. Alright. Next is RTH. How do we calculate RTH? So to calculate RTH, first again remove RL from the circuit. Then uh, we deactivate.
Sir, could you show the diagram once again?
Um, yeah, yeah. You have just now joined.
Sir, like 5 minutes ago.
Okay, okay. Yeah, this is the diagram. Let me complete the writing, then I can again revise, no problem. So you just write
Okay,
down
sir.
the method to calculate VTH and RTH. So for RTH, you remove RL and deactivate all sources. Okay. Now what kind of sources we have? We have voltage sources. So deactivating a voltage source means what? Short circuiting it. All right. If this is a voltage source, what do you mean by deactivating it? Like this. Did you get this? And if it is a current source, how do you deactivate it? Open circuit. So let's say I have a current source like this. You will make it open circuit. That is what we mean by deactivating all sources. Remove RL, deactivate all sources, and then third part, calculate resistance between terminals A and B. So that is called as RTH, or we can also call it RAB. Don't worry, when we will solve a numerical, we will revise everything again. Alright. So I repeat, for VTH we remove RL, calculate the voltage across A and B terminals. And for RTH we remove RL, deactivate all sources and calculate the resistance between A and B. Yeah, so again I revise what we have discussed so far. So in Thevenin's theorem, let's say we have a complex circuit, and at the output we have terminals A and B where we have connected a load resistor. Now this complex circuit can be replaced by a single voltage source VTH, which is Thevenin's voltage, in series with a single resistance RTH. Alright, between points A and B, and then you can connect back your RL, load resistor RL back. So this is Thevenin's theorem. And how to calculate Thevenin's theorem? Thevenin's equivalent voltage. We remove RL, remove load resistor, calculate the voltage across A and B terminals, that is called as VAB, VTH or VOC. Then to calculate RTH, we remove RL, deactivate all sources. What do you mean by deactivating all sources? Voltage source becomes short circuit and current source become open circuit. And then calculate the resistance between A and B. Alright. So are you ready to solve a numerical to understand it better? Everyone?
Yes.
Alright.
Yes.
So now please write along with me. So let's solve numerical number 1 today. Alright. So I am writing find I of 5 ohm. What do you understand by it? I am writing in short form. This is current flowing through 5 ohm resistance. I of 5 ohm. Okay. By Thevenin's theorem. So find current flowing through 5 ohm resistance by Thevenin's theorem. And this is my circuit. Please draw the circuit along. Here we have a voltage source 20 volt. This is 10 volt, 6 ohm, 1 ohm, 2 ohm, 3 ohm, and this is 5 ohm. Let me know when the circuit is completed. Completed? Can I start the explanation?
Done, sir. Yes.
All right. So now please concentrate. Now, what is my complex circuit? Acha, first of all, which current we have to find, which resistor? Uh, 5 ohm, right? So call that resistor as RL and mark these points as A and B. So please do that in your books also. So where is my complex circuit over here? This is my complex circuit. All right. And this complex circuit can gets converted into a voltage source in series with a resistance. So this is RTH and VTH. And then we connect back your RL. So we need to find the value of next VTH and RTH. Alright, this is called as Thevenin's equivalent circuit. This is what we want to find. Alright, let me know if I am too fast so that I can slow it down. So far you have understood what to do?
So, but what is
Yes.
VTH over here?
Sorry?
So, what is VTH over here?
Thevenin's voltage, we need to find that value. So this entire
Okay.
complex circuit will behave as if it is there is a single voltage source with RTH, with a single resistance RTH. Okay, we'll replace them with this too, and then the current which is flowing. I mean, you can apply mesh analysis, anything. The current which is flowing through this 5 ohm resistance will be same as current flowing over here. So that's what is Thevenin's theorem. Okay, so
So,
it's
that
like,
RTH is the common resistance, you see.
yeah, we will find out. You will understand now how we will find out. We have to calculate the value of VTH and RTH, then make this Thevenin's equivalent circuit, and from here calculate the current IRL, let's say. So what will be IRL over here? It will be VTH upon RTH plus RL. Is that correct? Yes or no?
Yes.
It's
Yes,
a
sir.
simple current is voltage divided by resistance, right? So now what we are saying is let's calculate the value of RTH and VTH. Okay, and then we'll make this circuit again and then find the current through 5 ohm resistance. Is that fine? This is the theorem. Till here, any doubt? Alright, so
No.
let's calculate VTH first. Calculate RTH first. RTH is much simpler. Okay, so let's calculate. So for RTH, what we will do? We remove RL.
RTH will be 6 ohms.
Sorry,
RTH will be 6 ohms.
RTH will be, no, it's not 6 ohms. That's what. Just have patience. We will solve that. I'm writing these things for your understanding. So please let me, complete it, and then you will find out. So we remove RL. What is the procedure? And we replace 10 volt voltage source and 20 volt voltage source with a short circuit. Yes or no? That's what the procedure is. And then we calculate resistance between A and B terminal. So that is RAB or RTH. Now this is my circuit, right? Let me just, yeah, this is my circuit. Now let me draw the circuit for RTH. How do we do it? Wherever you see a voltage source, replace it by a short circuit, like this, and draw the resistors as it is. Now there is another voltage source over here also, right? Yeah, and you have terminal A and B. Okay, let me write the resistors. Did you understand what are we doing? Yeah, we have replaced
So,
the
what is
volt.
ASC over here?
What is
ASC.
ASC?
So, you know,
अच्छा तो
replace
नहीं
10
नहीं
volt
नहीं,
to
with a short circuit, with a this is short form for short circuit. I have written SC. Okay, so we replace 10 volt and 20 volt voltage source with a short circuit. This is the short circuit, right? And we remove RL.
yes, sir.
So we have removed RL, and now we find the RAB here. Now I suppose you all have been taught how to calculate equivalent resistance, right? The resistance in a network. Yes or no? You all have solved, na? Source transformation, star to delta, delta to star, how to find equivalent resistance. Did you understand the
Yes.
procedure first? Tell me. Did you understand how I have drawn this green circuit?
Yes, sir.
Okay. Now from this circuit we will calculate RAB. Now tell me how to do that. So over here 6 ohm resistance is in parallel with 1 ohm resistance, correct? These two are in parallel. 6 ohm is parallel to 1 ohm. So please calculate 6 ohm in parallel to 1 ohm. How do you do that? 6 into 1 divided by 6 plus 1. That's coming out to be, how much it comes out to be? You have your calculator, please let me know.
6/7.
No, no, you have to tell in fraction form in calculator.
0.857.
Got it? Yes, correct. So now this, I'll club it and I make the circuit now. So we got it as, this is 0.857 ohms. Then we have 2 ohms over here. And then we have 3 ohms. And then we have A and B. This is what we have, right? Okay, so let me redraw the circuit over here. So this is B, A. Now how we calculate RAB? Tell me next. Now these two resistance are in series, right? Yes or no? So it will be 0.857 plus 2, which will be 2.857 ohms. Are you agreeing to this? Yes or no? Okay. And then your final, your circuit get reduced to this network now. This is RAB. Now tell me, this 2.857 ohms resistor and 3 ohm resistor are in series or parallel now? Hello? Are they are in series or parallel?
Parallel.
Yeah, so parallel. So what is your
Parallel.
RAB? RAB is equal to RTH is 2.857 ohms parallel to 3 ohms. So please calculate this and let me know what's the value. Anyone know the value? You have to calculate in the calculator. So you know whenever there are two parallel resistance, the result will be lesser than the lowest value. Alright. I am getting this as 1.4633. Please cross check at your end. Can you please cross check at your end whether RAB is
Yes, sir, it's correct.
alright. So it is clear what we have done so far. We have calculated RTH. Alright. And this is how we have done it. Any doubts so far? So can I proceed with the next part? Yeah, let me know.
Yes, sir.
Okay. Then we'll calculate VTH. Alright. So for this, what is the procedure? The procedure is very simple. Remove RL and then find voltage across A and B terminals. That is VAB or VTH. Alright. So let me redraw the circuit. So you also need to redraw the circuit, the main circuit. Okay. So let me redraw it over here. Yeah, I have a 10-volt voltage source, 6 ohm resistance, 1 ohm, 2 ohm, and 3 ohm. And here I have 20-volt voltage source. and here I have A and B point, right? So between A and B, I will remove RL. So no RL is connected. All right. Here no RL is connected. So we have drawn the same circuit as this, but we have removed the RL. All right. Are you following?
Yes, sir.
Okay. Now we will calculate this voltage plus minus VAB, or we call it VTH, or we call it VOC, between A and B. Now tell me, how will you calculate this? Now, whenever you calculate any voltage, you start from B and you go above. Okay? Go above. Now what do we want over here? I mean VAB, right? So VAB, what it will be? Can you tell me? VAB will be, here we are going from minus to plus. So rise in potential. So 20. Okay? 20 into, 20 plus or minus. Now plus or minus, how will you decide? If I decide the current inside, now I can use mesh analysis and find current I1 and I2. Okay, now I2 is going down and we are going up. So we are against the current, so that will be plus 3 I2. So what is VAB? 20 plus 3 I2. No need, we need to find I2. Are you following what I'm doing? We are finding open circuit voltage VAB and we are going from B to A. Alright. So when we go from B to A, there is a rise in potential in the voltage. So it will be positive. And if we consider the current direction of I2 as down and we are going up, so that will be plus 3 I2. Did you understand this? Yeah.
Yes, sir.
Alright. Now how will you calculate I1 and I2? We'll use simple mesh analysis. So I think mesh analysis you're comfortable, right? Hello.
Yes, sir.
Okay, so even though that, I will repeat it again. Will apply KVL to mesh 1. Which is my mesh 1? This one. Okay, this is my mesh 1 and this is my mesh 2. So mesh 1, when you apply, again I repeat here. So now we are going from minus plus. So that will be plus 10. Then this current will be minus 6 I1, minus 6 I1. And then this current will be I1 minus I2, because we are in the first loop. So 1 into I1 minus I2 is equal to 0. So did you understand how we have applied this KVL?
So this is in first mesh, na?
Yeah, first mesh. So plus
Got
10
it, sir.
minus 6 I1 minus I1 minus I2. Now we rearrange this. So this becomes minus 7 I1 plus I2 is equal to minus 10. This is equation number 1. Any problem till here?
No, sir.
Okay. Then we apply KVL to mesh 2. Now please concentrate over here. How will apply? So here we are in loop number 2. So it will be, we'll consider this 1 ohm resistor. It will be I2 minus I1 minus of I2 minus I1. Okay. Minus 2 I2. Do we have 3 anything? Can we write 3 I2? Yes or no?
No.
Yes, we can now, right? Current is flowing now to 3 ohm resistance. So we can write minus 3 I2 is equal to 0. Yes or no? We have I1. I1 is said, 1 ohm resistance is said by I1 and I2. 2 ohm and 3 ohm is not said by anyone. So we can directly write it minus. Alright. Now we arrange this properly. So it will be I1 minus 6 I2 is equal to 0. This we call it equation number 2. Now I don't know which technique you have been following for mesh analysis, but this is how we do it. We write in the form of a matrix. Y'all are also doing in this form?
So we use calculator. Yes. Like I'm,
Ha.
I'm used to
After
calculator.
this, after this we use calculator only. But let's see how we write it. So here we write I1 and I2. Just listen to this technique. I1 and I2 we write, right? So here we write coefficient of I1 and I2. So here it is -7, I2 is 1, and here it is 10, -10. Did you understand what did we do? Same thing only it is. Okay. So for second one, what do we write? 1, -6, 0. Understood? And then then you go into calculator and put these numbers, right? Actually you do this only, right? In calculator you put these numbers and get the value of I1 and I2. Yes or no?
Yes, yes.
So directly this writing in this matrix form will actually help you out. So please calculate and let me know I1 and I2. How much is I1 and I2? I hope you know how to solve it in calculator. You have done it many times. You must have done it many times. Can I know the answer? I1 and I2. All of you have to solve this, or else there is no point of keeping this online session, because you have to practice everything. Anyone with the value? How much is I1? Hello.
So 1 minute, sir.
Okay, okay. So everyone else, please calculate I1 and I2 also. And if anyone gets the answer, let me know. It will hardly take less than 10 seconds. Use your calculator and get me the value. I1 and I2. Till then I'll keep that VAB. I'll write that statement and keep it ready. VAB or VTH is 20 plus.
Sir, I1 is 1.46.
No, tell me in fractional form.
Okay.
So I am getting 60 by 41. Is it that?
Yes, yes.
And this is 10 by 41, right?
Yes, sir.
And what is VAB? 20 plus 3I2. We have already discussed that. So we'll write over here 20 plus 3 into I2, 10 by 41. So calculate VAB now. It will come out to be 20.73. Just check. Yes?
Yes, sir.
Alright. So we got the value of VTH RTH. Now next what we do is we'll draw the Thevenin's equivalent circuit. So this is point number 3. So write down along with me Thevenin's equivalent circuit. Alright. So what is Thevenin's equivalent circuit? VTH, RTH, then we have A and B, and you connect back your RL over here. So how much was the value of RL? 5 ohm. So please draw this circuit. And what is the value of VTH RTH we got? VTH we got it as 20.73. RTH we got it as 1.463 ohm, and RL was 5 ohm. Now we need to find current flowing through 5 ohm resistance. And that is very easy from here, right? So current flowing through 5 ohm resistance will be 20.73 divided by 1.436 plus 5. So calculate this number. This will come out to be 3.2 amperes. And that's the answer. Please cross check this. So actually, solving with Thevenin's theorem is about breaking a complex circuit into a simpler network of VTH and RTH, and hence finding current flowing through the load resistance. RL is the load resistance. Everyone clear about it? And have you all completed this?
Yes, sir. Completed.
Did you all understand?
Yes, sir.
Okay, great. So everyone completed? Can you reply in the chat box and tell me whether if you have a doubt? I'm just glancing it through once more. Thevenin's theorem.
So what is Thevenin's resistance basically? Like the equivalent resistance of the circuit?
Yeah, without voltage sources and RL.
Okay.
It's equivalent resistance only. Na? See, we are calculating equivalent resistance of the circuit. So basically what are we doing is, if we solve this by mesh analysis normally, how do we solve this by mesh analysis? Mesh number 1, I1, I2, I3, right? Whatever current we get there, okay, current flowing through 5 ohm resistance, that current and this current will match 3.2 amperes. Did you get it?
So what matches could you say again?
Sorry,
Like the what you say will match you?
the current, if you calculate mesh analysis over here and find out the current using mesh analysis, current flowing through 5 ohm resistance, that current which you get over there and this current which you got using Thevenin's theorem will be same.
Oh,
So
okay,
you're
okay.
reducing this complex network. Actually, that is what we started, right? We reduce this complex network with VTH and RTH. That's it.
Got it, sir.
Okay. So this will be more clear if we solve this in a tool called as LTspice. I'll share you everything. Let me build it. This was taught to you in the class, LTspice.
No.
No,
Okay.
sir.
Okay. Now, no problem. I am recording this lecture. You can watch it in recording also, and I'll share the link and everything. So you go to a new schematic, and here I will build the circuit in front of you only. Okay. Then you will have a better understanding of what is going on. All right. So you just watch for a few 1 or 2 minutes. I'll make the circuit. So you go over here in components and type their voltage. So this is my voltage, 10 volt. I require 20 volt also. So I'll press Control R to rotate. Control R to rotate. Then here are the resistors. You'll add resistors 1 and 2. If I want to move anything, I'll use this button, move, and keep it over here. Okay. Then I require two more resistors. So I'll take over here and I want to change the orientation. So Control R, I'll keep it over here. Another, I'll keep it over here. And then also I'll require one more resistor for the RL. Let's say. Okay. And now I'll join them together with the wire. These resistors also I'll join them. Then also I have to add a ground. So this is my ground. I'll add a ground here. And then I connect this to the ground. Alright. I made my circuit. similar to this. Now this I will right click and give the value as 10 volt. This value is 6. This value is 2. I'll right click on R and give the values. This is 3 and this is load RL. Let me call it load RL. And this is value is 5. Alright. And the value of this voltage source is 20. Now, one limitation of LTspice is that whenever current is flowing into the voltage source, that is from positive to negative, if it is flowing from positive to negative, then it's considered that current as positive. If the current is leaving the voltage source, okay, that current is taken as negative by LTspice. Okay, so don't get confused if you get a negative sign. So I'll go to simulate. To simulate this, click on run and I select DC operating point. .op will come. You click on OK. So the moment you click on OK, what is the value of current flowing through 5 ohm resistance?
3.2 ampere.
See, now I want to find I of RL. So I of RL is, let me maximize this and show it to you. Okay, I need to calculate I of RL. See, I'll keep it over here. Where is I of RL? Here. See, did you get this? Don't worry about the negative sign. I told you, right? LTspice treats the voltage, treats the current leaving out of the voltage source as negative. Did you get it?
Yes.
And if you want this current to be positive, this is 3.2, and how much did we get? 3.2. All right. So it's matching. Now, if I want a positive current, what I will do is I'll make a cut over here and I will add a voltage source, a zero voltage source. A zero voltage source will do you no harm. Zero value voltage source, but it will act as a current meter. Okay, and give the value of the voltage source. If you add a 0 volt voltage source, it will not do anything, but current flowing through this V3 will be the actual current flowing through RL. All right, now let's calculate I of V3. See, calculate I of V3 is coming positive. Did you get it? So this is the true current flowing through the resistance RL, load resistance RL. Understood this? Yeah.
Yes.
Now let's
Yes, sir.
apply Thevenin's theorem. Let us do what we did over here. So in the first step, what did we do for calculating RTH or RAB? Let's apply it over here only and see. So I'll do it here only. Okay. So what did we do? We short circuited V1 and V2, right? And we remove RL. Yes or no? So this I replace it by a short circuit. You can see what the green color circuit which I have drawn on the left hand side. And these points are actually A and B. Now, how do you propose we calculate this A and B? Resistance between A and B. This is resistance between point A and this is point B. So you know we can apply a test source. So I'll apply voltage over here. This is just to calculate resistance in LTspice. This is not a technique. Just to calculate resistance. So how do you calculate resistance? I can calculate resistance by voltage divided by the current. I mean, what is the resistance actually? V is equal to IR. So what is I? Hello. So basically what we do is we apply a 1 volt test source. Okay. Let me call it as V test. Alright. Now let's say how much current I'll get. V of I test. Don't worry about the negative sign. So this is the amount of current we get, right? Now I'll show you how it works. So I'll go to the draft and I'll add a comment. So what I want is I want a resistance RAB. So what is resistance RAB? V test divided by current flowing through V test. Okay. Now what is V test voltage? 1 volt. And don't consider this as a negative because I already told you LTspice treats the current flowing out of the positive terminal as negative. So 1 divided by 0.6833. Okay. So please tell me what is this number? 1 divided by 0.6833. Someone please do it in the calculator and let me know. What's the value? 1 divided by 0.6833. How much is the value?
1.4634.
Isn't it matching with this value? RAB?
Yes.
So understood what are we doing? I mean, we are in the right track. It's all correct. It's all making sense, right? Okay, understood.
Yeah.
Now we put back the sources. Okay, let me just we just remove this test source and we add the sources back. So let me go over here, add the voltage source over here back. For we are calculating VAB or VTH like this. All right, I have need to connect them back to calculate VTH. This value is 10 volt. This value is 20 volt, and we need to calculate VAB. Okay, so I'll click on simulate, run. I know what is VAB. How much is VAB? 20.73, right? Let's see whether we get it or no. So I'll go to simulate, click on run. VAB. VA VAB is what? VA minus VB. Okay, so it's 0.73 minus or minus 20. So how much is that? 20.73, right? Hello, are you
Yes,
following?
sir.
See, again I repeat, I'll simulate, run. So what is VAB over here? VA minus VB. So VA minus VB is 20.73 and it's exactly matching. Alright? Okay, understood. So VAB is coming out to be,
Yes, sir.
according to what we did, VAB or VTH is coming out to be 20.73. It's coming exact. Now what we do is we'll make a Thevenin's equivalent circuit. So let me make a Thevenin's equivalent circuit. Okay, yeah, and I'll add a voltage source and also add RL. I'll making this circuit. Okay, connecting them with the wire. Also I need to add the ground. You can do that by watching this video again. I'll share you the link. Everything I'll share it with you all. 1.463. This voltage is 20.73, and the value of this is I of 5 ohm. Now to get the pure value, I mean to get the proper value of you're getting the current negative, right? So how to do it? You add a 0 volt test source over here. Okay, so that you get the current positive. That's the only reason we are connecting a 0 volt test source. 0 volt test source will not disturb the circuit, but it will act as a current meter. So now current flowing through RL, that this we call it as RL. It might come negative, but current flowing through V4 will be the current flowing through RL. So let me simulate and show it to you. So V of I of V4. See, I of V4 is how much? Can you see this? And this. See, correct? Yes or no? 3.2 amperes, 3.2 amperes. That is what we get. And this is your Thevenin's equivalent circuit. You can check the current flowing through RL also. So it's coming positive. So it's correct. See, both are positive. Current flowing through RL is 3.20749. So understood how to use this tool and calculate all the answers on your own. All right. So this tool link, I'll give you the download. I'll share you the download link, everything. You can watch this recording and you do it yourself and verify the answers. So it's making more sense right now what we did, and we have verified that using LTspice simulation. Okay. So can we start with the next numerical, everyone?
Yeah.
All right.
Yes, sir.
I hope you're following. So um, let's solve another one. So write down numerical number. Wait a second. Numerical number 2. Let's go to a new page. Okay. So write down, find current flowing through 40 ohm resistance using Thevenin's theorem. And what is my circuit? My circuit is this. Okay, I have to draw the register properly. This is 10 ohm. Please draw this circuit in your books. 30 ohm. This is 40 ohm, 20 ohm, 15 ohm, and this is 2 volt. Okay, and we have to find the current flowing through 40 ohm resistance. So this is my RL. Whichever resistance we want to find the current, that we name it as RL, and these points I call it as A and B. All right, have you drawn the circuit? Can we start? Everyone has drawn the circuit?
Yes, sir.
Okay. Now we start, and first thing we calculate is RTH. So how do you calculate RTH? Remove RL. Okay. Let me write over here. So first thing you do over here is remove RL, and then short circuit 2 volt voltage source. So the circuit will become like this. So these are my 4 resistance: 10 ohm, 20 ohm, 30 ohm, and 15 ohm. Now when we short circuit these 2 points, we short circuit like this, right? So instead of short circuiting like this, can I short circuit from inside? It means one and the same thing, right? Do you agree? Hello?
Yes, sir.
Okay. And now what are the points A and B? This is A and this is B. Now we have to calculate R resistance between point A and B, RAB. Now how do you do that? Anyone has any idea? So which two resistance are in parallel or are in series? Can you tell? Which resistance are in series or parallel? Please don't keep it one-way communication. You all also speak up. I'm taking this lecture for you all. You have any idea how to do this further?
Sir, 10 ohm and 20 ohm resistor are in parallel.
No, they are not in parallel. This is the mistake.
Because the current will split now.
No, no, no. You're making a mistake.
In the first circuit, the current will split.
The current will split. Yeah, then this is also connected now. Now let's see this. What I'm. Now please concentrate.
Acha, okay, understood.
No, 10 ohm and 20 ohm are not in parallel. Actually, they are not even in series. Just give me a minute. My writing pad is little bit misbehaving. Okay, so let me call this point as point C. So this also is point C, right? So I can draw the same circuit as follows. See here. This is A. Okay, this is point C. This is 10 ohm and this is 30 ohm. Okay, and below also I'll draw the same thing. This is 20 ohm and this is 15 ohm. Now do you see the picture correctly? And this is B. So this is the same circuit. Now tell me which resistors are in parallel and which are in series. Yeah, can you see this? These two resistors, 10 ohm parallel to 30 ohm, and this is 20 ohm parallel to 15 ohm. So quickly calculate this and let me know. Yeah, let me know the value please. 10 parallel to 30 ohm. Hello. I want the answers from you all so that you all are solving it on your books. In your books. 10 ohm parallel to 30 ohm. How much is the value? Please don't take this much time. We have to cover Norton's theorem also today. Hello.
7.5 ohm.
Yeah.
7.5.
And 20 parallel to 15. 20 ohm parallel to 15. 15 ohm.
8.57.
Yeah. Now these two resistance will be in series, right? Here, here. This is A, this is B, this is 7.5 and this is 8.57. So what is RAB or RTH? 7.5 plus 8.757. So how much is it? It's actually 16.07. Just cross check. Are you all getting this? Yes or no?
Yes.
Okay, let's proceed forward. Now, for the second case, for finding VTH. VTH. So what do we do in calculating VTH? We remove RL and calculate the voltage between A and B points. So calculate VAB or VTH. Alright. So let me redraw the original circuit. I'll remove load RL, okay? So this is the original circuit which I have, and I have connected a voltage source from outside. Okay, this is 10 ohm. Don't draw this, wait, just wait. Let me complete the explanation. So instead of showing this outside, can I show it from inside? Yes. And what are my points A and B? These are my points A and B. This is point A and this is B. Okay. And I've removed load RL, right? So I can add this voltage source, 2 volt. Now from here, this is, you can treat it as a ground because there are 2 more points going to the ground. Sometimes it's called as a reference point or a datum point. Okay. You all know about it, ground. Okay, nodal analysis you must have studied, right? A reference node or a, where all the
Yes, sir.
points meet. Now, how do you calculate VAB? Now, I told you before, you start from below. You start from down B and then go to up, then go up. Okay. Now, let me call current flowing in this loop as I1, current flowing in this loop as I2. Now, tell me what is VAB? Tell me what is VAB? You're going from down
So
to
do we
up.
have to use mesh analysis?
Sorry?
Do we have to use mesh analysis?
I am telling you from here it is. Here. How much is VAB? From here you go up, right? And your current is going down. So it will be 15 plus 15 I2. And here also. Okay. Um, okay. First let me calculate that and then we'll come to this. So you're saying you need to use mesh analysis. Why you need to do mesh analysis? So if I calculate the current over here like this, see, it's not necessary that always we go for mesh analysis. It's not required sometimes. Sometimes the solution is even simpler. Let me show you how. Okay, my PDF is stuck. Just wait a second. I was actually trying to save it and it got stuck. It will come back. Yeah. So I have saved the PDF. Okay, let me show it to you. So let us say current flowing to over here is I1. Now the same current will flow through this 30 ohm resistance. Yes or no? Are correct? And here the resistance flowing through 20 ohm resistance is how? And the same current will flow to 15 ohm. I2 will flow through 20 and 15. I1 will flow from 10 and 30. Alright. Now can you calculate I1 and I2? Can you tell me what is I1 and I2? I1 is current flowing in this loop. So what is I1? Voltage divided by total resistance 10 plus 30. Are you getting it? So 2 by 40 amperes. Did you understand? Yes or no? Hello. Did you understand how we have written I1?
Yes, sir.
And I2 similarly 2 volt divided by 20 plus 15. So that will be 2 by 35 amperes. Now tell me what is VAB. Okay, so this current is flowing like this, I1, and this current is flowing like this, I2. Now tell me what is VAB or VTH. So we'll start from down. So we'll go over here. Okay, so current and this direction is same. So we'll write minus 15 I2. Then we go above. We are going from bottom to top and the current is flowing in the reverse direction. So it will be plus 30 I1. Did you get it? Understood what we have done over here? What is VAB or VTH? So it is minus 15 times 2 by 35 plus 30 into 2 by 40. So calculate this. I hope you're following. So VTH comes out to be 0.64. Please verify this. Are you following and getting the same answer? Hello.
Yes, yes.
Okay. Now after this, what do we do? I hope you have noted it down. Let me know if something is left out. Now we draw the Thevenin's equivalent circuit. Okay. So what is a Thevenin's equivalent circuit? Everything is replaced by a single voltage source in series with RTH, and you have point A and B. Put back your RL. RL we have removed, right? Now we put it back. Now what are the values? Tell me. VTH is 0.64. RTH is how much? 16.07, and RL is 40 ohm. And we need to find the current through 40 ohm. So I of 40 ohm will be VTH divided by RTH plus RL. So I of 40 ohm will be 0.64 divided by 16.07 plus 40. So please calculate this number. This will come out to be 0.011 ampere. Please check your answers. So this will complete this numerical. Any doubts you all have, you can ask till the time being. If you have not, if something, some part of the explanation which you have not clear about this numerical, you can ask right now, because it will be difficult for me to revise this again. So today we'll do only Thevenin's and Norton's, and tomorrow we'll complete. Tomorrow we have to take one more session on maximum power and superposition theorem, because from next lecture onwards we are starting with module number 2 for all the regular students. Okay, and
Sir,
including you all. Yes.
sir, can you repeat how did you calculate VAB?
Okay. Yeah. Fine. So we go. See here. I'll explain again. So let's say this is my V. I am redrawing it. This is the point of intersection. Okay. This is A. This is B. And the current flowing in the loops, in their loops correspondingly, this is I1 and this is I2 correspondingly. Okay. And this is connected to the ground. And this value is 30, and lower one value is how much? 15. So what you do is you start from below and go up. All right. Okay. So now calculate VAB. Okay, wait a second. So VAB will be, you start from below. Below you're going top, right? So when you go in the same direction as the current, that current will be treated as negative. So minus 15 I2. If you go against the direction of current, that current will be taken as positive. So plus 30 I1. That's how you calculate VAB. Are you understanding?
Okay, sir.
So
Yes, sir.
the same thing we have done over here. So always start from B and then go up. If the current is in the same direction, then treat it as negative. If it is in the opposite direction, treat it as positive. Simple. Understood? Can we move on?
Yes.
Yes, sir.
Okay. So now we'll go to, I mean, we are solving two numericals. In the class also I have solved around two numericals. So I'll share all the PDFs, all the 10 lectures PDFs with you all. 11th lecture I've taken a test in the class. So that also I will share it with you all, the solution, everything. Now we'll start with Norton's theorem. So till 12 o'clock, whatever we can cover, we'll cover it up. We'll start with Norton's theorem. Do you know what is source transformation?
So the sum we didn't complete it. I think.
Sorry,
We didn't complete the sum you were given before.
you all didn't complete this.
Oh, sorry, sir. I didn't complete it. My bad.
You're completed, no?
So 1 minute, sir.
This is VTH RTH. Please write along from next time. I mean, I understand. I'm giving you all time. So whenever I write at my speed, you can write, right? For calculation, I should give you time, and that I'm giving already.
Yes, yes.
Because we have limited time now. I have further commitments after 12 today. So that's why I have to complete by 12. Can I proceed ahead?
Yes, yes.
So Norton's theorem, what is Thevenin's theorem? Let us revise. Then you will understand Norton's theorem very well. It's similar to Thevenin's only. So let us revise what we did in Norton's theorem, Thevenin's theorem. Then eventually we'll answer your question about Norton's theorem also. Okay. So any complex circuit, okay, you take the two terminals, call it A and B, and connect a load resistance RL. So this, according to Thevenin's theorem, gets converted into a single voltage source in series with a resistance. And you have A and B, connect back your RL over here. So this is RL. This is called as RTH, Thevenin's resistance, and this is called as Thevenin's voltage. And this is my complex network, and this circuit is called as Thevenin's equivalent circuit. Okay. Now, do you know what is source transformation? I guess it is discussed in your last lecture, right? In the C6 division. What is Thevenin's? What is source transformation? Hello.
Converting start network to delta network.
No, 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 no. That is not source transformation. Source transformation means you convert a voltage source in series with a resistance to a current source in parallel to a resistance. This is source transformation, right? Yes or no?
Yes.
This is what we have studied. That is exactly Norton's theorem. So I call this current as IN and I call that resistance as RN. And this is point A and B, RL. So a complex network, this is Norton's theorem. So please kindly draw. Okay. Norton's theorem is any complex network can be converted into a single current source in parallel with resistance. So IN is called as Norton's current, or it is also called as or ISC, short circuit current. Okay. And Rn is called as Norton's resistance. Now good news is it is same as Thevenin's resistance. The procedure to calculate Rn and RTH is same. So this half is I mean Norton's and the Thevenin's resistance are one and the same thing only. Norton's current is different thing. Thevenin's voltage was open circuit voltage. This is short circuit current IN. And now we will learn to calculate. We'll learn how to calculate IN and RN. So please, you have written up till here. Can I proceed ahead? Hello.
Yes, sir.
So 1 minute.
For Rn, the procedure is same. That is remove RL, deactivate all sources, and then calculate resistance between A and B. So I'm not writing it. I'm only writing for IN. What is the procedure to calculate IN? So let's write down calculation of Norton's current. IN, sorry. We call it IN or ISC. How do we do it? These are the steps. Please write down the steps. So step number 1 is remove RL. Okay. Step number 2 is short circuit the load terminals. So what do you mean by short circuiting the load terminals A and B? Short circuit terminal A and B and then find the current IN or ISC. So these are the steps. You'll understand better when we'll solve a numerical. Have you written the steps? So are we ready to start with a numerical? Hello.
Yeah.
Okay. I hope you have written. RN and RTH are same, so I'm not discussing it again. So let's start. Right, slide down numerical for today. It's numerical number 3. So write down the statement, please. Find I of 4 ohm, that is current flowing through 4 ohm resistance using Norton's theorem. So here is my circuit. Yeah, this is 2 ohm. This is 5 ampere, 2 ampere, 4 ohm, 2 ohm, and this is 6 volt. All right. Please write it along with me. 4 ohm resistance. You want the current to, find the current flowing through 4 ohm. So 4 ohm is my RL, and these are my points A and B across RL. Now what does the Norton's theorem do? Norton theorems will reduce this complex network. So this is my complex network. Let me use a different color. This is my complex circuit. Okay, I'll replace this complex circuit with a current source in parallel with a resistance. That resistance is A and B. So this resistance is Rn and this is In. Are you following? So we need to calculate In and Rn. So this is the Norton's equivalent circuit. Did you understand the agenda? What we need to find out? Yes, In and Rn. And then put it in the Norton's equivalent circuit and find the current flowing through IL over here. IRL. Can we start? Hello?
Start, sir.
Yes or no?
Yes, yes.
So let's start. First we'll start with calculation of Rn, or we can also call it RTH or RAB. So what's the procedure to do that? Let us write it down. I hope you are writing everything down. Remove RL and deactivate sources. There are 3 sources over here, 2 current sources and 1 voltage source. So what will happen to current source when we deactivate them? They will become open or short. What will happen to current sources when they are deactivated? See, voltage source will become short circuit. Current source will become what? Hello? Open circuit.
Open circuit.
Yes. So the same network, and then you calculate, you find RAB. Now listen very, very carefully what I'm doing. So I'm redrawing the circuit for Rn, right? So what happens to current source? Open circuit. Then I'm drawing this resistor, 2 ohm resistor. The 6 volt voltage source will be short circuit. This 2 ampere current source will be open circuit. And here are points A and B. I've disconnected RL. Alright. So let's see what has remained. This is how we do it, right? It is open circuit, and short circuit. Now tell me what is RAB from here. What do you see? How much is RAB? This is open circuit, this is short, this is open again. Come on, tell me. In front of you it is. What is RAB? Yeah, students, come on. Hello. How much is RAB? Please tell me. It's in front of your screens.
2 ohms.
Yes, it is 2 ohms only. This is 2 ohms. Yeah, you rightly said. Because the resistance you see over here is 2 ohms. See? Between this and this network, this is the 2 ohms resistor. Rest doesn't matter anything at all. So everything is open circuit over here. So it doesn't matter. Even if you don't connect these wires. They are open circuit anyway. Did you understand?
Yes.
Can we move on to iron now? Yes? So for the iron, listen very, very carefully. Okay. Let me redraw the circuit. And please write along. Let me redraw the original circuit. So this is 6 volt. This is 2 ampere. This will be 2 ampere. And between R and N, A and B, this is 6 volt. Alright. So what do we do over here for IN? We remove RL. Okay. We have removed RL. Alright. RN is gone between, it's not present between A and B anymore. Then second, we short circuit A and B. So short circuit A and B means like this. Short circuit it. Then find IN or short circuit current. So what is short circuit current over here? Can anyone tell me? This one. This is the current. Now I can draw it little like this. This also is a short circuit, right? So what is the current? This current flowing over here. Short circuit current is called as IN or ISC. Okay, understood? Yeah, what to do? We have to find this current. So what you do is you short circuit A and B and find the current over here, IN. So that will be a Norton's current. Yes or no?
Yes.
Now how do we proceed further? You want to use mesh analysis? Yes or no? Or you want to use any other theorem? Any other circuit technique? Can we use
Mesh
mesh?
analysis.
Okay.
Yes.
So there are three loops. Loop number 1, I1. Loop number 2, I2. Loop number 3, I3. Now tell me what is I3? Just looking at the circuit.
2 ampere.
Sorry? How much?
2 ampere.
No, 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 no. How much is I3? What did you tell?
2 ampere.
No, it's not 2 ampere. How it is 2 ampere? See, this 2 ampere current source is shared by I2 and I3. So it's not I3's alone. We have I2 also. I2 will call it ki it's mine, and I3 you're calling it is mine. So no, it's not that. Tell me what is I3? I3 is IN. That is what we have written, na? I3 is IN. Now tell me what is I1? Just looking at the circuit, I1 is 5 ampere because 5 ampere is only shared by I1, not anyone alone. Are you following?
Yes, sir.
So basically we need to find I3 and I1. Now, can we apply mesh in loop number 2? No, na? Because it's a problem of a super mesh. You know super mesh?
Yes, sir.
What is a super mesh? Whenever a current source is shared between two loops, so this 2 ampere current source is shared between loop 2 and 3. So whenever that happens, your super mesh is applicable. So what is super mesh? Around the loop, you apply your KVL here, around the loop, but not within this. Are you following? So this yellow color portion which I have marked, in this loop, you have to find the current. And what is 2? How is 2 ampere related to I2 and I3? That is super mesh ka equation. How do you write? Hello. How do you proceed further with this? Tell me. So we write super mesh ka equation. See, I3 is going in the same direction of 2 ampere and I2 is going opposite direction. So we'll write I3 minus I2 is 2 ampere. So this is equation number 1. We want what? I3 and I2. I1 is already known to us. So we have got one equation. What about the second one? How do we apply? We apply KVL to super mesh. What is super mesh? This yellow color portion. So tell me what is the answer? How to write the equation? So here we'll start. So here we'll write minus 2. What you will write? Minus 2 I2 minus I1, na?
I2 minus I1
Then
minus 6.
this is plus minus, so minus 6. And then nothing is there. This is just IN. So equal to 0. Did you get it? How we have written this? See, we have to apply the KVL around the loop now, because here we cannot apply the KVL in loop 1 and 2. So this yellow color portion is my new loop now. So in this new loop, this we write minus 2 I2 minus I1. This is minus 6, and here we have nothing. So equal to 0. To rearrange this, here you have 2 I1 minus 2 I2 is equal to 6. So solve one. Acha, I1 is known to you, right? 2 into 5, 2 I2 is equal to 6. So how much is 2 I2? Equal to 4, right? And how much is I2 then? Equal to 2 ampere. No need to solve mesh also. Directly we got the answer I2. So if we know the value of I2, can we find I3? Yes, from equation number 1. So from 1, I3 minus 2 is equal to 2.
4.
So I3 is 4 ampere, which is equal to IN, or short circuit current. So please note it down fast. If you have any, if you require any clarity in anything, you tell me now. I've kept the entire numerical in front of you. So take your one minute and let me know if you have any doubt. I'll explain that again. Clear it is, everyone? How do we apply super mesh and all? Because that has been covered, right? Understood? Can we proceed?
Yes.
Yes, sir.
Okay. So C part is draw the Norton's equivalent circuit. So Norton's equivalent circuit is here. IN in parallel to RN, Norton's resistance. You have point A and B, and between A and B, connect your RL back. RL is over here. Alright. Now we need to find the current flowing through this. Now let me add the values. ISC is 4 ampere. What was RN? 2 ohm, right? And RL is 4 ohm. And we need to calculate I of 4 ohm. How do we calculate over here? Do you know current division rule by CDR? So I of 4 ohm is other resistance value divided by total resistance into current. This is CDR. So other resistance value is 2 ohm divided by 2 plus 4 into 4. This 4 ampere. Okay, this is ohms. So how much it will be? 4 by 3 ampere. So I of 4 ohm will be 4 by 3 amperes. So that's the answer. Any doubt over here? Hello. So this we have achieved by
No.
Norton's theorem. Hello. Did you get the answer? 4 by 3? Yes, no. You require more time.
1 second. Done, sir.
Okay, great. Okay, that's great. Now, uh, let's solve another numerical on Norton's theorem. Are we ready? Hello?
Yes.
Okay. Numerical number 4. I hope you all are following the Norton's and Thevenin's theorem and you are comfortable in that now. Let's start. Now this was one of the numericals which was asked in the test, the practice test. So numerical number 4. Okay. Find the current in 1 ohm resistance, I of 1 ohm, using Norton's theorem. And the circuit diagram is as follows. Two ampere, this is 1 ampere, this is 2 ohm, this is 4 volt. So this is the circuit diagram. Please note it down quickly. This is the last numerical for today. Tomorrow we'll solve maximum power and superposition theorem. I'll tell you the timing details later. Are we ready? Yeah? Have you drawn the diagram?
Yes, sir.
Alright. So which is RL? 1 ohm, right? So this is RL and this is point A and B. So let's start. So first we'll calculate Rn. You know the procedure for Rn, right? What do we do? Every time, if you don't remember, write it down. You remove RL and deactivate all sources, and then calculate the resistance between A and B terminals. So let's do that. 4 volt voltage source is short circuited. This is 2 ohm. Remove RL, so load RL will be gone. This is A, point A. Okay. This is open circuit above, and this also is open circuit. Okay, this is very challenging now. Many students have made an error here in the exam. Tell me, what is RAB from this network? Come on. Hello. Tell me, what is RAB? RAB in this network is what? Anyone please give the answer?
Is it 2 ohm plus 3 ohm? 5.
No, 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 no. This is what many students made the mistake. How it is 2 ohm and 3 ohm? See, 3 ohm and point B. Are they connected? A and B, are they
No.
connected via open circuit है ना यहाँ पे open circuit है यहाँ पे short circuit है. So if I redraw the circuit, it will look like this. Point A and B. A and B के बीच में क्या connected है?
2 ohm.
And other side, we have 3 ohm, but this is open circuit, correct? ऐसे है ना? This is the way, na? This open circuit, so this resistance 3 ohm becomes redundant. So RAB is just 2 ohm. So this becomes only 2 ohms between A and B. So RAB is equal to RTH. Please note it down. And I hope you are following this. Understood? Before writing anything or thinking anything, think about a little bit. Don't just directly believe on, what is the standard technique. Just think also. Done? Completed? Hello? Can I proceed? You have written?
Yes, sir.
And it's important to draw these diagrams. Without drawing these diagrams, it's impossible to determine these things. Let me save the file. Okay, now we are calculating IN. So that's second thing, IN. What is IN called as? Norton's current or ISE. So what's the procedure to do that? Remove RL, then SC stands for short circuit, A and B terminals, and then find IN or ISE. Okay, so let me redraw the original circuit as it is without RL. So this is 4 volt. So you have to also draw this. This is point A. This is 3 ohm. This will be 2 amperes. And this will be 1 ampere, I guess. This is 1 ampere only, na? 1 ampere. Okay, this will be 2 ampere. And where are my points A and B? A and B is here. This is B. This is point A. Okay, and between point A and B, remove RL. I have removed RL and short circuit it. Short circuit it means this. And then find the current. So this is the current, IN. So this current I need to find out. Now how will you solve this using mesh or any nodal analysis? What do you see over here? Do you see 3 loops? Yeah, students, please respond. Do you see 3 loops over here?
Yes, yes.
So this is I1, this is I2, and this loop 3, I3. Now tell me what is IN?
I1.
No, I1, IN is said by I1 and I2. Okay, when it is said, it's not I1s alone, it's I2s also. Okay, so now I1 and IN direction is same, so I1 will be in the same direction and I2 will be opposite. Did you understand this? This is very important to understand. First, before deciding on the current, see if it is said with other. IN is said with I1 and I2, so it will be I1 minus I2 because I2 direction is opposite as IN. That's why negative. Did this make sense, everyone? Yes, no,
Yes, sir.
what? Okay. Similarly, what is I2? Now this will be challenging. Do it. I mean, give the answer properly. Is I2 said by anything else? Yes or no? Is I2 said by anything? 2 ampere current source said by anyone else?
No.
So how much it is? I2?
2
No. Minus 2. See the direction, na? Direction is opposite, na? I2 is coming down and this 2 ampere current source is going up. So it is minus 2 amperes. Got it? Similarly, what is I3? From the
plus
circuit?
1 ampere.
Yes, plus 1 ampere. Perfectly said. Good. Okay, now we only want I1. So how will you determine I1? We'll apply KVL to loop 1. So this is my loop 1. This is minus plus. So I'll get plus 4 minus 2 I1 minus I3. And this is nothing. I mean, this is just a sort. So equal to 0. Did you understand? We have applied into loop 1. Loop 1 is this. So plus 4 minus 2 I1 minus I3. Here it is nothing, equal to 0. Did you get it? Now in this you can substitute the values. 2 I1 plus twice I3, twice I3 is 1, equal to 0. So how much is I1? Twice I1 is 6. So I1 is how much? 3 ampere. Okay. Now if I know the value of I1 and I2, what is IN? I1 minus I2, which
2
will be
ampere.
2 ampere. Yeah. So IN will
No,
be,
sir. IN is 2 ampere.
no, IN is 5 amperes. See this part. Correct now? IN is I1 minus I2 and I1 is 3. I2 is 2 minus 2. So it's 5 ampere. Did you get it?
Okay, sir. Got it, sir. Got it.
Alright. So this is how I calculate Norton's current. I hope it is clear.
Sir,
Every time we need not
one doubt.
apply. Sorry?
Sir, when you apply KVL to loop 1, we can't use mesh 1 and mesh 2 instead.
We have applied KVL only to loop 1 only, na? This is mesh only. Array, mesh and loop are one and the same thing.
Ah, that I got it. But we're using here mesh 1 and mesh 2. Oh, sorry, mesh 1 and mesh 3. So we can't use the first and second mesh.
Why?
Hmm.
Why we cannot use
We can't use mesh 1 and mesh 2 instead.
mesh 1 and 3? I didn't get you.
Sir, see, here you have used I1 and I3 as the current. Here in mesh 1 and mesh 3.
Mesh 1 and
So,
this one you are saying minus 2 I1 minus I3.
minus 2 I1 minus I3.
Used
That
what?
was
This
I1.
is because this 2 ampere, 2 ohm resistance is set between 1 and 3. And nothing is said between 1 and 2. No resistor is said, na? So what will I write?
Yeah, yeah. Oh, okay, got it.
There should be something na to share. Okay?
Yeah. I got it now.
Yeah. Now third part is draw the Norton's equivalent circuit. So what is Norton's equivalent circuit? A current source, we have a parallel resistance Rn, and between point A and B you connect load RL. Got it? Now IN is 5 amperes. What was Rn? 2 ohm, no? And RL is how much? 1 ohm. Now calculate I of 1 ohm from here. So I of 1 ohm is what? By CDR, by current division rule, other resistance, that is 2 divided by 2 plus 1 into 5 ampere current source. So I of 1 ohm will be how much? 3.33. Just cross check, and it's going down. Got it? This is the answer. And we have completed the contents which we were supposed to cover today. Okay? Now anything related to Norton's theorem, Thevenin's theorem, you can ask now, because we have solved two numericals each, and also I have shown you how to do it in LTspice. You want me to show this in LTspice once, or you will manage on your own? Hello? You have understood how we have written I of 1 ohm, 2 divided by 2 plus 1 into 5? That is called as current division rule.
Got it.
Okay? So if you have any doubt, I'll remain active for 1 minute more, and then I'll leave for the day. And tomorrow we will continue with superposition and maximum power. So with that complete, we will be completing module number 1 also. And by today I'll share you all the handouts which I've shared in my class. Whatever you have written today, it's fine, but what I've written in the class, it's much more you know systematically written. Let's, for example, let me show you. This I've covered in my class. See this Norton's theorem, Thevenin's theorem statement. Little bit more cleaner. Okay. So these PDFs you have not got, right? This is what I've covered with in my class. So I'll share all these PDFs with you. Is that fine?
Yes.
And today in 2 hours we have completed Thevenin's and Norton's. That takes that much of time. And tomorrow also we have to sit together, because Monday onwards we will be starting with module number 2. So tomorrow again 2 hours, 1.5 or 2 hours will take to complete maximum power and superposition theorem. Okay. So any further doubts, anyone, or you want to speak up? Any other thing not clear before I leave for the
So
day?
tomorrow is same time, no?
No. Timing I will tell you.
Okay, sir.
Okay. So that's it for today. Um, so yeah, we'll meet tomorrow then. Okay.
Thank you, sir.
Yeah. Thank you.
Bye, sir. Thank you, sir.
Yeah. Bye.